How does vapor pressure lead to condensation? Imagine a glass of cold water on a warm day. The air around it feels humid, and tiny water droplets start forming on the outside of the glass. What's happening there? It's all about vapor pressure and how it influences condensation. Vapor pressure is the pressure exerted by water molecules in the vapor phase when they are in balance with the liquid water in a closed system at a specific temperature. This means some water molecules are constantly escaping from the liquid into the air, creating vapor. The faster they escape, the higher the vapor pressure gets. Now, think of vapor pressure as a kind of pressure limit. When the vapor pressure reaches a certain level, called the equilibrium vapor pressure, the rate of molecules leaving the liquid equals the rate of molecules returning. This balance point depends on the temperature. As the temperature drops, fewer molecules have enough energy to stay in the vapor phase, so the vapor pressure decreases. But what happens if the vapor pressure in the air becomes higher than the surrounding pressure? Or if the vapor cools down? The molecules lose kinetic energy, slow down, and start sticking back to the liquid surface. When this happens, vapor molecules collide with the liquid and stick, turning back into liquid droplets. This process is condensation. In practical terms, when warm vapor contacts a cooler surface, it cools down quickly. The vapor's molecules lose energy, and their vapor pressure drops below the saturation point. As a result, the vapor condenses into tiny droplets, which you see as fog, dew, or water droplets on a cold glass. In a closed system, if the vapor becomes saturated, meaning the vapor pressure reaches the maximum possible at that temperature, any additional cooling or compression causes more molecules to condense. This is why cooling a gas or increasing its pressure can lead to condensation. Understanding how vapor pressure influences condensation helps explain natural phenomena like cloud formation. When warm, moist air rises and cools, the vapor pressure drops, and water vapor condenses into tiny droplets that form clouds. It also explains how refrigeration and air conditioning systems work by controlling vapor pressure to manage condensation. So, vapor pressure leads to condensation when it reaches a point where molecules can no longer stay in the vapor phase because they lose energy or the surrounding pressure changes. This balance between evaporation and condensation is what makes phase changes happen naturally and in engineered systems.